Okay, so we have been talking about systems of equations. We just talked about inequalities. We are now going to be talking about systems of linear equalities. So this is not a lot different from what we have been doing. So when we've been talking about just systems of equations, the part of the lines that we have been caring about is where those two lines intersect, where they cross. And this is very similar to what we've been talking about. So when we think about inequalities versus just equations, when we graph them, one of the main differences that we have when we graph inequalities is we shade in the direction that the inequality is true, right? Because when we are talking about lines, we have specific solutions to that line. But when we're talking about inequalities, we have a whole bunch of options to choose from. So when I'm looking at a system of linear inequalities, what I'm going to care about is where those two lines intersect, or where those two shaded regions intersect, rather. So a system of inequalities, pretty straightforward, is when I have two or more inequalities. Okay, so an example that we could have for this could be something like y is greater than x plus 2, and then we could also have y is less than or equal to negative 1/2 x minus 3. So when we were solving systems of equations, we just graphed those two lines on the same coordinate plane and looked at where they crossed, right? Well, I can do a similar thing here. I'm going to graph these two inequalities on the same coordinate plane, and what I'm going to be paying attention to is where their two shaded regions cross over. So if I open this up, let's go, oh, I already have Desmos open. Look at that. Okay. So we're going to go into projector mode here. If I had, our first one was y is greater than x plus 2. And then I would also have y is less than or equal to negative 1/2 x minus 3. Let's get this out of the way a little bit. So here I have my two inequalities that are graphed on the same coordinate plane. And so the part that I care about is not the solid green part or the solid blue part. What I care about is where those two pieces overlap. So I have a whole bunch of solutions in the middle of all of this, right? Anything in this overlapped region would be a solution. So I could have a solution of negative 10, 0. I could have a solution of negative 15, negative 5. I could have a solution of negative 6, negative 1. Couple things to pay attention to. So I could have a solution of negative 1, 0, but I could not have a solution of negative 5, negative 3. Here's why. Negative 1, 0 is on this solid line. The solid line means that I can include it. So anything on that line can be part of my solution set where it overlaps. But negative 5, negative 3 is on the dotted line, which means that I'm not including that. Okay, so if we go back to our notes then, a solution of linear inequalities is just an ordered pair xy that make both true. That make both true. So I listed off several that would work, but one that I remember is negative 6, negative 1. Right? That is a solution. It's not the only one, right? It's just one of my solutions to that system of inequalities. Okay, so my solutions to systems of inequalities are written in an ordered pair, x, y. So this is asking me to tell whether each ordered pair is a solution of the system of linear inequalities. So the way I figure out if it's a solution or not, I plug in x and y to both inequalities. If it comes out true for both, then I'm good. I'm good to go. So I have -2, 1. So I'm going to do 1 is greater than 3 times -2. So that means that I would have 1 is greater than -6. That is true. That checks out. Then I would have 1 is less than or equal to -2, which is going to be a +2 minus 2. 1 is less than or equal to 0. That is not true. So this is not a solution. Okay? Go ahead and try the second one then on your own. So pause this here and try part B by yourself. Okay, part B was also not a solution. Again, it worked for the first one. 4 is greater than 0. Did not work for the second one. 4 is not less than or equal to -2. Okay. So we now, when we're solving a system of linear inequalities, we are only going to be solving them by graphing. That's going to be the best way for us to solve these. The reason being, there's not a very easy way right now for us to say what our solution is, because we're used to just saying like, well, the solution is this point, or the solution is this line, but that's not the case. With systems of linear equalities, we form kind of odd shapes, right? And so we're only going to solve these by graphing. So this first one, y is greater than or equal to -1. Well, I can look at this and know, I know that's a horizontal line. Greater than or equal to means that I'm going to use a solid line. So this is going to be a solid horizontal line at y equals -1. So I'm going to set this first one up here. And y is greater than or equal to -1, which means that I'm going to shade this above the line. Didn't really want gray, but that'll work. I'm going to shade this up here. Okay? Second one then is y is less than -x plus 2. Well, I know that this one's going to start at the y-intercept of 2. My slope is -1. Means I'm going to go down 1 over 1. Down 1 over 1. And this one is going to be a dotted line because it's just less than. Okay, so we're going to do the best here. This is my dotted line. Okay, and then it is y is less than. So we're going to shade underneath. What this means then is my solution happens right in here. So here's what I want to do to help us be able to recognize what are solutions, what are not solutions. Let's go ahead and create a table. So solutions over here. I'm going to put not solutions over here so that we can kind of see the difference. So one of the solutions that I could have in here would be -3, -1. -3, -1, right down here. Maybe I'll put these in a different color. Let's do red. -3, -1. I can include this one because it's on the solid line, right? It's in my solution set, it's on the solid line, so I can go ahead and include that one. Another one that I could include is 0, 0, right here. 0, 0 falls in both, it's true for both of those. Another solution I could put in here is -5, 2. So let's see this. -5, 2. Happens right about here. Okay, those are three solutions that are in the solution of my system of inequalities. So one solution that is not would be 0, 2. So let's see where 0, 2 is. 0, 2 is right up here. The reason why this is not in my solution set is because it is on the dotted line. Okay, so I'm not including values that fall on the dotted line because I don't include those. Another one that's not is 4, 1. This one may seem obvious, but 4, 1 is just a solution set to my first inequality, y is greater than or equal to negative 1, but not my second one. So 4, 1 is not in my solution set. Another one that's not would be negative 3, negative 2. Negative 3, negative 2 falls right down here. So again, that one is a solution to one of my inequalities, just not both of them. Okay. This next one, so the easiest way that we can graph lines is when they're in slope-intercept form, right? Y equals mx plus b. So the first step here is I would want to put these in slope-intercept form. So I'm going to subtract 2x from both sides to the first one. That means that I have y is less than negative 1 minus 2x. So my y-intercept is at negative 1. My slope is negative 2, so I'm going to go down 2 to the right 1. And this is going to be a dotted line because I'm not including, it's just a less than. So I'm not going to include that. It's just going to be a dotted line here. Oof, that is not a good dotted line. We're just going to, I don't know what we're going to do. We'll just kind of connect these dots here. Maybe that will help. It's a little better. Okay. Y is less than that, so that means that I need to take my highlighter. Y is getting smaller, so it's going to happen down here. So then I'll do the same thing with this next one. Again, I'm going to subtract 2x from both sides. So now I have y is greater than or equal to 3 minus 2x. So my y-intercept's at 3. My slope is negative 2, so we're going to go down 2 to the right 1 again. Hopefully you have already recognized what's going on with these two lines. But we're going to talk about it a little bit more because when we're dealing with inequalities, this is going to be a little less obvious of a thing. This one's going to be a solid line because it is greater than or equal to. Greater than or equal to means that I am going to shade in this direction. So this is an example of a no solution. These two inequalities will never intersect. This is an example of no solution. So before now, when we have looked at parallel lines, we have just been able to kind of automatically assume that if lines are parallel, that there is no solution. But that is not the case anymore when it comes to inequalities. Okay, so something that I would like you to take note of is having parallel inequalities does not automatically mean no solution. It depends on where the shading goes. Does not automatically mean no solution. It depends on where the shading goes. So if, for example, I had that the second one was y is less than or equal to So if I had that, the second one instead was y is less than or equal to 3 minus 2x. Now instead of shading above that line, I would shade below it. So if I shaded below this line, now I do have a solution. My solution is everything below the first line, right? It's everything below this dotted line. So there are ways in which parallel lines will have solutions. So just because two lines are parallel does not automatically mean that I have no solution when it comes to inequalities. So make sure that you remember that, because that is something that is different. Okay, so there are also going to be times where we're going to look at graphs and we're going to have to come up with a system of linear inequalities for that graph. So let's go ahead and start with the dotted line first. Here's what I would like to do, is I like to look at the line itself, figure out what the equation of that line is, and then figure out what inequality sign I need after that. So if I look at this dotted line, I can notice, well, I notice that my y-intercept happens down here at -1. So I'm going to need a y. I'm going to need something in between, but I have a -1. And my slope, in order to get to the next point, I go down 1 over 1 every single time, which means my slope is -1. So my equation of this line is -1 minus x, or -x minus 1, whichever works for you. I know that it's a dotted line. I can see that. So the dotted line means that I'm going to either use a less than or a greater than sign. Here's what else I'm noticing is that this shading is happening up here. So in order to shade above this line, that means that y needs to be greater than, because I'm going above the line. That's the first one. Let's get rid of this so that we can look at the second one. So let's look at the solid line then. Y is something. My y-intercept happens up here at 4. And now I'm going up 1 over 1 every single time to get to the next point. So that means I have a slope of +1 plus x. Again, I'm shading on the side where y is getting bigger. This is a solid line, which means that I'm going to include the points on that line. So y needs to be greater than or equal to 4 plus x. That is the two inequalities that form the system of inequalities. Okay, let's do a word problem. So you have at most 7 hours to spend. At most 7 hours to spend playing soccer and swimming. So I'm just going to go ahead and designate these x and y. You want to spend at least 2 hours playing soccer and more than 2 hours swimming. Write a graph, write and graph a system that represents the situation. Okay. So when we talked about what a system of inequalities was at the beginning, I said that we could have 2 or more inequalities. Here's a case where we are going to set up 3 different inequalities. I have 3 inequalities here. So my first one is the total amount of time that I'm spending exercising, whatever it is. So playing soccer and swimming, x plus y, needs to be at most 7 hours, so it needs to be less than or equal to 7. Second thing I know is that I want to spend at least 2 hours playing soccer. So x needs to be greater than or equal to 2, at least. The third inequality that I have to work with is I want to spend more than 2 hours swimming, so y just needs to be greater than 2. Now I just graphed my inequalities. So this first one, if I want to get y by itself, I'll subtract x. So y is less than or equal to 7 minus x. Means I'm going to start up here at 7. My slope is -1. I'm going to use a solid line because it includes it, less than or equal to. So a solid line here. I need it to be less than or equal to, so we are going to shade below it. Okay, next I have that x needs to be greater than or equal to 2. This is also going to be a solid line at x equals 2. X needs to be greater than, so we are going to shade to the right, because x needs to get bigger. My last one then is y is greater than 2. In this case, I'm going to use a dotted line at y equals 2. Y needs to be greater than, so we're going to shade above this line. What that means then is we have this overlap right here, this little triangle is where all of our inequalities overlap. So what it's asking is, how much time can I spend on each activity? Well, I have some possible solutions here. One of my possible solutions could be at the point 2, 3. Let's go do a different color so we can see this again. 2, 3 could be one of my solutions. I could have a solution at 3, 3, which means that I could spend 3 hours doing each. I could have a solution at 4, 3, right here. Okay, there's a couple others. I think there's about a total of 6 different solutions. If we're using whole numbers, so we could obviously use fractions and it would look different. But all of our solutions then fall in that triangle. The only place where I cannot have any solutions is down here at y equals 2. Okay, this is a dotted line, which means that none of my solutions can fall on that line. Everything has to be above it. Otherwise, those are all of the solutions that I can have here. Okay, this back page then I'm just going to have you do on your own. So this top part, you're going to graph these two inequalities and shade them the way that you need to shade them to find the solution. And then these bottom 4 have you figure out what the system of inequalities is in each of the graphs. So go ahead and wrap these up on your own, and that is all for section 5.7.